All right. Okay, so we are doing 4-1 antiderivatives and indefinite integrals. That is exactly what it sounds like. We are underiving things. Okay, so we are going backwards. So there is a process to it where we can do bigger things, but some of these simpler ones that are on this slide, like we would be able to do without the skill to do it. We can just kind of think backwards. So we're going to assume these are the derivatives. What was it before? Okay, so we're going to look at this and decide what then, change that to make that smaller, would f be? So if 2x is the derivative, what is the derivative of? Okay. Now, could there be anything else with it that would also give it a 2x? Okay, so it could be plus any number, and we're going to call it c. Okay, so yeah, you add a number. So then you stop and check yourself. Do the derivative in your brain. Does that give you back where we started? Okay, so a lot of these will be easy ways to check yourself. Okay, all right. So then on a little bit of a harder side, what has the derivative of x?
X squared over 2.
Very good. Or 1/2 x squared plus some constant c, because again, any number, I could put 1 million there, the derivative would still be just x. So you can do 1/2 x squared or x squared over 2, because you needed that exponent to come down. So you can kind of think like, oh, I needed to have an exponent of 2, but then the 2 is not there. What is it now? So what would have the derivative of x squared? So what was the exponent before? Cubed. But there's not a 3 in front of it, right? So then you can do, say, this time let's write it as a fraction in front, 1/3 x cubed. Or you could have done x cubed over 3 plus some constant c. You have to always account for that constant. It's always there. And so that's the indefinite part, is it's not definite, it's not decided. Okay, when we get to definite, then there will be a number there. When it's indefinite, no number. Okay, you'll have c instead. All right, make it a little more complicated. So keep in mind, that's x to the negative 2. What would the exponent have been before? A negative 1. Okay. Which means when I would have done that derivative, I would have negative 1 x to the negative 1. But it's not negative, right? It's positive, which means it would have needed to start with a negative. Does that make sense? There's also a process to that, but this is just a way of thinking. So you can logically, like, I just did this, my answer doesn't make sense. After I teach you the process, you can kind of do that. All right, so similarly, if I have it this way, what would it have to be? Negative 1 over x squared. Good. Nope. Negative. It will be negative. A little bit more than that. Because if you think about it, if it's x to the negative 2, and I multiply it in front, it would be negative 2x to the negative 3, right? But there's not a 2. So the negative helps with the negative, but how do I not have a 2? Oh, wait, How about that? Does that make sense? So if you were to move that x to the negative 2 back up. All right, this one should be simple. What is cosine the derivative of? There you go. And no sign change necessary. Still plus c, because you can still have a constant added outside of it. So that's what we're doing, is we're underiving things. So this way you guys had to just think backwards. There's actually a process. Okay, so it's pretty simple. Oh, not scrolling down, scrolling over. All right, so I put the page number of this on purpose. Here is all of your antiderivatives for the most, probably that you just ever need to know. But I kind of want to look at these. So they gave you the differentiation on the left, and then they gave you the anti-differentiation, also known as integration. This is the same thing. Antiderivative. I zoomed in so much. I'm like, why is that so fluffy? These are also known as antiderivatives. Kind of like differential and take the derivative of, the same thing. Integration and antiderive are the same thing, or integrate. Okay, so if we kind of look at, so the antiderivative of 0 is just a constant. So you're undoing something. So like these kind of go together here. If you are antideriving a constant other than 0, it's going to be x plus that constant. Okay, so we're going to add this. So again, if you're thinking like the antiderivative of 1 is going to be x plus c. Okay, the antiderivative of 2, 2x plus c. Because if I would derive it, I would just get that number. Now, if I have any function at all, you can factor out numbers if it helps you. That's what this next one is saying, is that you can do that. Most importantly, I want to go here. Okay, so this is our power rule. So what that says is the antiderivative of any polynomial term, okay, I can add 1 to the exponent and divide by that exponent entirely. So like if I were antideriving x to the 5th power, I would have x to the 5 plus 1 power divided by 5 plus 1. So I'd have x to the 6 divided by 6. Okay, or you can do 1/6 if you want. There's no preference. I often will write these like this because sometimes it's just more useful. That's kind of up to you. It goes into your antiderivatives of your trig functions. So the antiderivative of cosine is sine. The antiderivative of sine is negative cosine. Okay, so watch those negatives or positives there. The antiderivative of e to the x is e to the x, just like the derivative of e to the x is e to the x. At this point, there's no such thing as chain rule at this point for derivatives. So you won't have anything that complicated to antiderive, okay? This one is also a really important one. The antiderivative of 1 over the x. If you picture that, that's x to the negative 1. If we were to do the adding to it, it would give us x to the 0, which is 1. And in a problem, that doesn't actually make sense for us to take it back there. Okay, so that's a different thing. That makes that, if we were to use that concept, it makes that and that the same, and it's not. Okay, so it's natural log absolute value of x. Just like when we did the derivative of natural log absolute value of x, it was 1 over x, okay? So don't do the exponent thing on 1 over a linear term, but you can do the exponent thing over anything 1 over anything else. Okay. All right, do I have any more over here? No. Hope I don't make you dizzy. Where is it? Aha. Okay, so some examples. Let me zoom out. We have 1 over x cubed. My suggestion is, and your textbook will ask you to do this, it'll want you to rewrite it. So I can rewrite this as the integral of x to the negative 3 dx. Also notice we're integrating a differential. Do you see the dx on it? That's what you just had on your test, was differentials. You will always integrate differentials. Okay, so like dy equals something dx. When you integrate both sides, you get y equals something with x's. Okay. All right, so then what I can do with this is I'll use the power rule they told me. Okay, basically this is an operation. It's saying take the antiderivative. So once you do it, you don't write the squiggle anymore. Okay, it's called the integrand, but you don't write it anymore. Okay, just like if I write square root of 4, the answer is not square root 2, which people do, and it's weird. Okay, so it's just 2. So what I'll do is I will add 1 to the exponent. I'm going to do this in a really annoying way, and we don't have to do it after the first time, but I want to write it out. I'm going to add 1 to the exponent, and I'm going to divide by exactly that, and then I'm going to put my plus c. Then I'm going to simplify it. You don't have to write that step out, except for on this first problem, I want you to, so you can have it to refer back to. Okay. So then I will have x to the negative 2 over negative 2 plus c. And you should rewrite that as negative 1 over 2x squared plus c. Okay. You are welcome, depending on your brain, to go straight from here to here. Okay, but don't do stuff that's going to make you mess up either. So maybe practice a lot before you get to that stage. All right, how can I rewrite the antiderivative of root x dx? X to the 1/2, good. So then I'm going to add 1 to the exponent, and we don't have to write that out, but what is 1 plus 1 1/2? 1/2. I accidentally. 3/2. Okay. I don't recommend writing it as a mixed number. Okay. That's just, it's not proper form. Just don't do it. It's weird. All right. Divided by technically 3/2 plus C. Now, I actually will go from here to here. What I'm getting ready to write is I know that if I divide by a fraction, I have a fraction exponent. That's the same as multiplying by the reciprocal. So instead of dividing by 3/2, I go ahead and just multiply by 2/3. You can do that, or you can write that middle step. That's okay. But don't leave a fraction in a fraction. Any questions on that? So you're adding 1 to the exponent and dividing by that exponent. For a power rule. So the 2 here, you can think about it being out front. The 2 is not affecting, it's not a product with, like we would need to use some sort of opposite product rule, which we don't actually have or anything like that. We need to just focus on the sign and we'll multiply that by 2. What is the antiderivative sign? It's going to be negative cosine because, think backwards, what's the derivative of cosine is negative sign. So you've kind of got to affect the check for that sign. So it's going to be negative 2 cosine x plus c. This one you may want to think about as the 3 being outside of it and it being 1 over x. What has a derivative of 1 over x is the natural log. Okay, so that's that one I put a star on that last one. So this is going to be 3 natural log absolute value of x plus c. That's more or less one you have to memorize, is that when there's a linear term on the bottom, you'll have to use something like that. Any questions? Takeaway from this that I want you to remember is the plus c. It's really important. Okay. If you Google antiderivative memes on the internet, half of them will talk about plus c. Like, don't forget it because it's the most commonly forgot thing. So I also tell people sometimes it helps you remember it, put your initial. It doesn't have to be c, can be anything. So I would put plus j on all of mine because it doesn't matter what it is. It's just some sort of variable, some sort of constant. There's a way to remind it. So if you are not going to remember plus c, you might remember plus your own initial. I had people too when they take their test, which obviously you get take-home tests right now, but they would write that at the top of their test to remind themselves to add c to everything. All right. I didn't mean to leave this here. That shouldn't be there. All right. So if I know it's on your paper and it's not on mine, but the antiderivative of just dx, and this is important to remember, is 1. Okay, it's really important to remember 1 plus c because if you think about it, this is the equivalent of this. Oh, just x. Yeah, sorry. Oh, they rewrote it. Actually, that's not the answer. So that's okay. But because of this, it's this. Okay, so that's one way to think about it. And so when I'm doing this antiderivative, because it's x to the 0, I'm going to add 1 to the exponent, and I get this. Okay, so don't let it throw you off. There's nothing there. That is why whenever we get to the point we're doing dy equals who cares dx at this point, when I integrate something, you really do it to both sides. If you're talking about equation, you'll get y equals whatever the other part is. Okay, is because the antiderivative of just d something is that something. Okay, plus c. All right, antiderivative of x plus 2. So what is the antiderivative of just x? So think add to the exponent, divide by that exponent. Current exponent is 1. X squared over 2, or 1/2 x squared. Plus the antiderivative of 2, keep in mind this is like 2x to the 0. So you're adding 1 to the exponent, dividing by that exponent. So you're going to be left with just 2x, and then don't forget your plus c. Now stop, do the derivative in your head. Bring the 2 down, 2's cancel, and I get just x plus just 2. The derivative of a whole number or any number constant is 0, so it's not written. So you can check your work. All right. Antiderivative now. Gets a little crazier. So you're going to add 1 to the exponent and divide by that exponent. What will the first term be? What is the antiderivative of 3x to the 4th? It's going to be x to what power? Okay. And then that means we have to divide by the 5th. So you could write it as 3x to the 5th over 5, or you can write it as 3/5 x to the 5th. That's up to you. Minus, add 1 to the exponent, divide by that exponent. What do you get? We'll get x cubed, right? What will the fraction be in front? 5 over 3. Good. If those reduced, you should reduce it. So if that were like 6 in front of it, you would have 2. Okay, you would have to reduce it. And then what's the antiderivative of x? Add 1 to the exponent, divide by the exponent. X squared over 2. Since I'm doing fractions right now in front, I'm going to keep it as fractions. But all of these could be written as fractions themselves. So I could have had 3x to the 5th over 5. 5x cubed over 3, x squared over 2. Plus c. Any questions on that? Prior to this, we were doing just individual terms, but we put it all together. Okay. Just these two. Okay. So this looks like a quotient, which we do not have the background to do. Okay. However, we can rewrite, simplify, be creative on how we do some of these things so that we're able to simplify it. Okay. So what I want to do is let's rewrite this. As long as we're rewriting it and not actually evaluating the antiderivative, it has to stick around, kind of like we do with limits. Okay, it sticks around until you actually evaluate it. So this is the same thing as sine x over 2 cosines, right? Because that's what squared means. And this seems a little weird, but sine x over cosine x. Sine over cosine is tangent, right? So this is the integral of tangent x, leaving 1 over cosine x, which is secant x. So that simplification comes from pre-calc, that you should be able to do that. But the antiderivative of tangent x, secant x, I'm going to try to avoid making you dizzy, but I'm going to go straight up because I know it's up here. Tangent x, secant x is just secant. Okay? So they expect you to memorize that. However, if you memorize the derivatives like you were supposed to, you basically have the antiderivatives memorized. Okay? So that's kind of a fun thing. So we have just secant x. Where is it? So this is secant x plus c. And that's because the derivative of secant is tangent x, secant x. Okay. When you end up with the sign, so if you have a cosine, it'll affect your signs. So be careful. If you're going to end up with a cosine as a result, you have to watch your signs. Be careful. All right. Then this one, I love this problem because it looks crazy, and it's not as bad as it looks. So what you want to do is simplify it. If you have division, you need to simplify because at this point, you don't have any division skills with antiderivatives. Okay, I will give them to you eventually, but for this stuff, it wouldn't matter what skills I give you in the future. You would still do this process for a problem like this. So what I would do is I'm going to divide by root x for both of these. So x divided by root x, that's x to the first, divided by x to the 1/2 is x to the 1/2. That first term simplifies to that. And then I have 1 over root x, which is x to the negative 1/2 dx. Do you see what I did there? Yeah, and think of it, if you're thinking of it more, maybe more of an easier term, if you had anything like this, you can divide this by 2 and divide this by 2. That's what we did. We just had only variables. Okay. Now we can integrate it. So add 1 to the exponent, divide by the exponent, but notice you're going to have fractions. So instead of dividing by a fraction, you can just multiply by the reciprocal. So x to the 1/2 gives us a power of x to the 3/2. Instead of dividing by 3/2, I'm going to multiply by what? 2/3. Okay, so that's the first term. Second term, add 1 to negative 1/2. Very good. And then multiply by the reciprocal, which is 2 plus c. So instead of having x to the 1/2 over 1/2, you would write it as 2x to the 1/2. Negative exponents often throw people off because they forget they're adding or they forget they're subtracting or they're mixing up the derivatives and antiderivatives. There will be problems where you do both within one, so just be careful to make sure you're increasing power or not. Okay. Try to circle that one. All righty. Okie dokie. We are going to now find the general solution of f prime of x equals e to the x. So what we have been doing is the general solution. It's not specific. Okay, so that's the indefinite. And then finding a particular solution would be more of a definite, except for the fact that it's actually asking for an output, not just definite. Okay. So we are finding the general solution of f prime of x equals e to the x, and then they gave us a condition f0, 3. That means x is 0, y is 3. Okay, that's what that's saying. Make sure you can interpret that to mean that. They won't always give it to you as an ordered pair, but they might, so it's important to see it both ways. So what we first need to do is we need to find f of x by integrating e to the x dx. Okay, so if it's asking for a general solution of this, you are going to integrate it. Now you have to write it properly as a differential, so you would need to put that dx with it. What is the antiderivative of e to the x? E to the x. And then plus c. Okay, so I have this. This is my general solution. Okay, so I circle that because it did ask for general solution. And then find the particular solution, which means I'm going to now use that ordered pair they gave me. Okay, so kind of picture this like if I was asking you to write the equation of a line, you have to go plug in a point or something like that. You have to go plug in this point. And so I will do f of 0 equals e to the 0 plus c, which is going to be equal to 3. So I don't really need that f of 0, but I do need the e to the 0 plus c equals 3 so I can find c. Okay. How would I get c by itself? Well, I would simplify first. What's e to the 0? 1. So I have 1 plus c equals 3, minus 1 from both sides. So that c is equal to 2. And then I'll rewrite my particular solution as f of x equals e to the x plus 2. That is a definite integral of the previous thing. Okay. There's this particular way to write definite integrals, but you'll end up solutions like that when you use. There won't be any plus c anymore. Definite integrals, though, you get an actual answer, like a number for it. All right, doing the same thing. We are finding the general solution for 9x squared minus x, and then we're going to find the particular solution that satisfies f of 2 equals 16. So we need to integrate 9x squared minus x dx, and that will give us our f of x. So what is the antiderivative of 9x squared? So you're going to add 1 to the exponent and divide by that exponent. 3x to the third. That was nice because it did simplify a little bit. That's great. And then what is the antiderivative of x? X squared over 2, yes. Okay, and then plus c. So this is your general solution. Particular solution, we need to actually go plug in our number. So I will do 3. And what am I plugging in? 2. So I have 3 times 2 cubed and 2 squared over 2 plus c equal to 16. And I'll solve for c. So 2 cubed is 8, and 8 times 3 is 24, plus 4, 2, plus c equals 16. And then you'll have 26, and then you'll subtract. Did I misadd something? I feel like I have a minus. Yes, you're right. Minus, minus. There we go. Beautiful. And what is c equal to? So then I rewrite it as f of x is equal to exactly what we had before. But this time I'm going to put in my, don't put plus minus 6, put just minus 6. Okay, if you're adding a negative, it's a subtraction. And that is your particular solution. They sometimes don't ask you for the general. You just have to find the general to get the particular. It's an important step to take. Any questions on that? All right, last part. A ball is thrown upward with an initial velocity of 64 feet per second from, and I need to zoom out so I can see it, an initial height of 80 feet. Is it coming? All right. We are going to find the position function given the height s as a function of time. Okay, so part A. We are given an initial velocity. The initial means like nothing has happened. So no distance has happened, which usually x is your distance. Okay, so we will have velocity of nothing happening. Okay, initial velocity is 64. Okay, that's important. That's an initial condition that we have. And we have an initial position as well. It from an initial height of 80 feet. So S is your height. And so we have 80. Okay. And then they don't tell you this always, but there is an initial velocity. Not velocity, acceleration. Okay. And that has to do with gravity pull. And the pull for gravity, that is feet, is negative 32. Okay. If you think about, depending on your units, it's negative 9.8. Okay. And then depending on your units, it's negative 32. So if you're using feet, then you're doing it. If it's, is it meters, is the negative 98? Yeah, 9.8. So we have all these. These are all really, really important. Here's why they're important. Because what I can do is I can antiderive, because remember that velocity is the first derivative of position. We talked about that before. And acceleration is the first derivative of velocity, meaning acceleration is the second derivative of position, if we go back what we had learned previously to do that. Okay, so what I want to do is I want to start filling in things so that I can start finding things. Okay, so if we start with, let's do our finding this. Let's antiderive that. So if I do the antiderivative of A, then I will be able to find my velocity function. Okay, so V is equal to that. So I'm going to antiderive negative 32. Since my variable is t, you'll write it as a differential with dt. Okay. What is the antiderivative of negative 32? This should be a t there. Since there's no variable, think of it like this. Right? Okay. So then that antiderivative is negative 32t plus c. So then now I need to go find c, because I don't want to antiderive it here, because then I'm going to have multiple c's in one problem. Okay. But I do have a situation to where I can find C, because I have V naught, or V naught is, depending on your calculus classes, they'll say that for initial condition. Okay, so my V of 0 is equal to negative 32 times 0 plus C, and it's equal to 64. So we can solve for C, and C is going to be 64. How nice. So I will rewrite this function. My velocity with respect to time is negative 32t plus my C, which is 64. Okay. So then to get our position function, we need to antiderive this. So S of t is going to be equal to the antiderivative of V of t. So we are antideriving dt negative 32t plus 64 dt. Okay. So what is the antiderivative of negative 32t? So increase your exponent, divide by that exponent. Yep, so negative 16 t squared. Good. Because you'll do negative 32 divided by 2. And then the antiderivative of 64 is 64, in this case t, but yes, it is your variable. Perfect. And then don't forget your plus c. So now to find c, I will use this initial condition, okay, that says when I plug in 0, it's going to be equal to, oh, not that one, this one, sorry, position function, equal to 80. So then C is, often they'll require a little more work to solve for C, but it's kind of nice that it's not that bad. And so then your position function that we were asked for in part A, S of t is equal to negative 16t squared, which is often the start of a lot of velocity, like ball dropping kind of problems that use gravity. All right, plus 64t plus 80. Okay. And really, it wasn't A of 0. I said A of 0. It should have been A of t. Any acceleration of a ball dropping problem would have been negative 32. Okay. So that was part A. Part B gets to be a lot easier. All right, what does it say, though? When does the ball hit the ground? So when is the position 0 is what it's asking. Okay, so when it's asking where a ball hit the ground, if you imagine it's been thrown, it comes back down, this is a height of 0. Okay, so you're essentially saying, when does this happen? When is your position 0? That's why we had to find the position function. They kind of set it up for us. My recommendation to solving this would be divide everything first by negative 16. Because all three of these terms are divisible by negative 16. What I do to one side, I do the other, which is why it's nice since it's an equation. And I will be left with t squared minus 4t minus 5 equals 0. And yay, it factors pretty easily. What multiplies negative 5 and adds negative 4?
T minus 5, T plus 1.
Awesome. Okay. Equals 0. So then I have a t of 5 and a t of negative 1. Which one of those answers is illogical? Negative 1. You can't have time of negative 1. That's silly. And we are dealing with seconds, so it is 5 seconds. So at time is 5 seconds, the ball has returned to the ground. Awesome. Which also implies if it had a negative 1 time, it didn't start at the ground, which makes sense because if a person's throwing it, their height has to be included in some degree. So the end. Homework is posted. Tomorrow I intended to finish notes, and we finished. So tomorrow, just homework. Okay.